Our next speaker, Jacopo, was already a little bit introduced by his colleague, because this is a double feature from Jena, which is both, as Haran said, the city of optics, but also has a big center on open hardware. So really driving this community forward with a lot of really different interesting projects. And it's great that also our next speaker, Jacopo Abramo, is joining us today, and he's representing the software side of open hardware, so to say, because that's also, of course, a really important aspect of this. And he'll be telling us about microscope control using Python with the ImSwitch system. Please go ahead, Jacopo.
All right, thank you for the introduction, and thank you also for the possibility of illustrating my work and also Oran's work that we are basically collaborating through the intermediacy of Benedict. So I will just give a brief introduction about myself first. I am actually not trained in sense of in the academia sense, because I started first after my master degree in engineering working into the automotive and the railway systems for 4 years. So I have more of an industry background myself. But then I switched back to academia after meeting Professor Christian Eggeling, and then I joined this group of the biophysical imaging group here in Jena, as his let's say software the techie guy, let's say. So in order to understand ImSwitch and the background in which was born, we have to first also understand the current situation that was around open source microscopy control. Especially, we have to go back at the beginning of the image processing, let's say, field. And the real big player that came around was actually ImageJ back in 1997, when it was first released from the National Institute of Health in America. And it basically became one of the biggest pillars of image processing in computational science. And it was following suit by Python by the first release of NumPy in 2006. But in this time, Java was still one of the most important languages used for developing systems, and specifically in this case also what came next, which is Micromanager, which was born as a plugin for ImageJ in order to control microscopes using an open source environment, and using C++ as a background, as a low-end interface to the drivers, while having a more high-level interface to these drivers via Java and using ImageJ. So this became one of the most important, I would say, let's say, tools in the open source microscopy, because it's the one that received the most contributions also for companies, because it's the one that has the most rich library of device adapters that we currently have at our disposal. There are some problems though with this, and the fact is that the Micromanager, it's not outdated in the architecture per se, but rather in the language technology that it's deploying. And this is something that the community is trying to tackle in a way that it comes back with the current times. And one other thing, which is a minor thing, I would say, is that the Micromanager is still limited to data streaming only for one channel at a time, because there is support for multiple cameras, but back in the time it was more of a hack in that sense. So in this overview, this is where ImSwitch was born in a couple of years ago from Xavier Casas Moreno from the Scilab Lab, from Professor Ilaria Testa group. And as you can see, it's fully developed in Python. It has a different architecture from the one that the Micromanager was using, which is called the Model View Representer. And I will explain later what this is. But I can already say that this provides a higher flexibility in the sense of how to create setups and how to manage different setups with the same code base. One nifty thing is that it's using Napari for image viewing. It's becoming one of the most contributed softwares, open source softwares right now in terms of for image processing. related to Python. And at the moment, ImSwitch is presenting a lot of widgets that span from image processing to also device control. I'm not going to go into detail too much. I will show you the links to the code repositories. And like Oran suggested, we also have a module dedicated for running Python scripts that are embedded into ImSwitch itself. So to run normal Python scripts by connecting directly to the hardware that ImSwitch controls. So this is an overview that is presented on the documentation of ImSwitch, just to give a brief overlook of what it looks like. So we have a series of widgets which are separated on the left for the detector control. So we have all the settings for CMOS cameras and the recording settings in relation to how many frames you want to collect, or if it's a time acquisition. There is also the possibility to do time-lapse scans and so on. On the right, we have the widgets presenting for laser control, for positioners, and also for scanning, because it's this has built-in features for confocal scanning. It was actually born because of this. So going back to the model viewer presenter architecture, this is what a general, let's say, implementation of ImSwitch looks like. So basically the viewer is a layer which records all the code related to the widgets or the user interface that one can develop to control their own setup. Then we have an intermediate layer, which is called the presenter. And it's basically the middleman that allows the communication between the widgets and the underlying part, which is the model, that represents the collection of source code needed to control the devices in order to actually communicate with the hardware. This is an example of a setup that I actually have right now in my laboratory. It's an IceCat setup, and we have three different cameras, three different channels, one for focus lock and two different, one for IceCat and one for fluorescence, and we have 3 stages and 2 lasers. And so this is usually how the communication works. Whenever we want to activate a laser, we press a button on the laser widget. The laser widget communicates with the controller, then sends a message through the communication channel and to the master controller. The master controller and the communication channel work in a way to send the proper commands to the underlying managers that then will communicate with the hardware. In this case, the laser manager with the laser widget will then goes back from here directly to the laser manager, and then either selecting one of the 2 lasers. In case, though, we want to have also image processing capabilities, such as real-time calculation of an FFT from one of the channels, there are already available some FFT widgets, or again, another widget, which is the focus lock, that takes the data directly from a dedicated channel for the focus lock and basically calculates on a PI feedback loop the current status of the focus, based on some preemptive starting points, of course. And the idea is that the code base for both setups is the same. What happens is that whenever we start ImSwitch in the beginning, we select a specific configuration through a JSON file that specifies all the information related to what that setup should look like. So if it has lasers, and which lasers, and for each laser, which laser, what kind of preemptive parameters need to be set up. In Python code, this is represented by a series of data classes that collect all these informations and then can be reused in order to create polymorphic objects. So one object that basically inherits from a base object and then implements a different sets of function depending on the kind of hardware it's controlling at the time. I have some links for the documentation. I hope that somehow I can share this presentation so all of you can have access to these links at some point. So very briefly, I'll try to go over the current pros and cons of the project. So one pros for me is that it's fully in Python and it's possible to integrate existing packages or other device layers. Specifically in this case, I'm referring to especially Micromanager, which is another project which is similar, which is connected to Micromanager, but it's more of a bridge from Python to the Java application of Micromanager. And it's been developed in the years for achieving high-speed data streaming and having also the full support of the micromanager device layer. So this is something I'm actually working on at the moment to try and integrate. ImSwitch is based on the Qt seamless and slot system, which is a very common system that's been using for a lot of GUIs, and it's pretty familiar and common for a lot of developers. And it's a very well-known and stable package. And then we also, like I mentioned, embedded the Napari as an image viewer for visualizing what the detectors are currently recording at the moment. And there's also the possibility to include existing plugins also in the workflow and making them communicate with the ImSwitch itself. Like I mentioned, higher configurability, and you only are loading the widgets that you need for the specific setup. It has a more structured architecture and easier to integrate new widgets, especially for in the case of basically reviewing the work that has been done from other people and trying to inherit from that one. And it has built-in support for scanning microscopy thanks to its dedicated widget, and it can also have multiple channels with the concurrent acquisition. The thing is that Python, unfortunately, has a big flaw, which is the GIL, that unfortunately kind of limits the true capability of multi-threading and concurrent execution. But this is something that in the future is probably gonna go away with the recent developments that they're doing in Python. At the moment, we have a limited documentation due to a low user base, even though this is growing and we're trying to expand and reaching out to other people that may be interested in this solution. And we also have a limited device support. But again, this is easily covered by integrating packages that have a strong background, such as, like I said, micromanager or Python microscope, or possibly other device layers as well. So in summary, I made this presentation only to make a point in relation to what's the current status of the open source software, because we have a lot of open hardware, but this also comes with a lot of open software, and there is a hard time bridging all the communication with all these devices together in order to create more complex but synchronized solutions. We have previous examples of something that this worked, like micromanager, but this has not withstood the test of time very gracefully. But I want to stress out that ImSwitch is not an attempt to reinvent the wheel, but rather to create a more efficient wheel. So taking what's being out there already and trying to push it together into a more cohesive community that is capable of using all these tools together into a single entry point. And to me, it also look like is a strong point. The fact that the Python is a language which is closer to newer graduate students that are coming on from academia, since I know that Java is not as popular as it was before. And you can just see the latest even Stack Overflow statistics in which you can see that Python is it became a more trusting language than the Java is at the moment. And we also have a lot of other plans for the future, especially our plugin system, in order to not conglomerate all the code base into a single point, and other features such as a high-speed device layer written in a different language than Python, just to achieve more performance, or an headless mode for connection to web interfaces, which is the way that actually OpenUC2, which is using ImSwitch at the moment, is doing. So this is a couple of useful links from my closing slide. I will just leave it here, and if you want for me to copy them, just tell me and let me know if you have any questions. Thank you for your time.